So today we're talking about observation, and this is the very first step of the scientific method. So if you've already done your do now, then you have watched the video and you've thought about some things that you've noticed. If you haven't, stop this, go back, watch a few minutes of that, and do that. Think about some things that you see, that you hear, and just kind of remember those because we'll talk about them later on. So what is observation? Observation is it's something that we do instinctively. It helps us decide when we're walking and we come to a busy road. We observe. We don't even think about it. We observe. We've been trained, look both ways, and we decide is it safe to go or not. But it's more than just noticing something. It involves perception. So we become aware of something through our senses. I'm going to give you our technical definition. Observation is collecting and recording information. So first of all, it involves our five senses: sight, smell, hearing, touch, and taste. This is how we observe the world around us. But we're doing more than just seeing or hearing or smelling. We're perceiving. So when we come to the edge of the road while we're walking, our eyes tell us if there are cars coming. We can hear traffic and we recognize something. So we're interpreting the things that we're perceiving. We know that if we step in front of a moving car, that it's dangerous, and so we wait. We wait till the road's clear. Observation is very important in science. Scientists use observation to, like I said, collect and record information. But then this enables us to develop and then test our hypothesis. So as we move through the scientific method, it all starts with observation. So yes, we can use our senses. We can use our sight to see a phenomenon, or we can smell something, or we can hear, we can touch, we can taste. But we also use tools. We use a microscope, a thermometer, radar, satellites, telescopes, and these help us to gather information about things that are beyond our immediate senses, beyond what we can see and hear firsthand. Think about like the space telescopes. They can see into deep space, which we can't see firsthand. We can't even see with just a regular telescope. So scientists use all of these tools to help collect and record information. Now, what we need to understand about observation is that it is a skill. And like most skills, it improves when we practice and we learn more about it. So continuing with our analogy about coming to the road, as we grow up, we gain more experience with crossing roads. When you were little, you didn't know to look both ways. We've been trained. We've practiced that skill. And so now we make better judgments about vehicle speed, about how far away it is, about safety. And observation is the same in science. We learn to observe more scientifically when, first of all, observations are come alongside an appropriate question, which is the second step that we looked at. So we observe and then we question, or we question and then we observe. We learn more. We learn to observe more scientifically when observations are connected with our growing background knowledge on the subject. Meaning, like if we're talking about chemistry, the more we learn about chemistry, then the more we can observe. And then when we are given the opportunity to share, to discuss, to debate what we've seen, which is why it's so important for us to discuss while we're having our class. That's why I want you to participate. Now think about water. We're all familiar with water. It is a very common substance that we interact with many times a day. We drink water, we wash our hands, we shower, we wash our dishes, all of these things, but we may not have observed it in a scientific manner. So think about questions like, does water have shape? Or can you compress water? And these kind of questions can make us observe water in a more meaningful way. So opportunities to experiment with water, to discuss our experiences with shaping it or compressing it, are likely to modify, to change our perception of something that we use every single day. Observation really is just the beginning of the scientific method. It's a good way to learn something new, to expand our knowledge, but it's only one small component of science. And rather than just piling up one observation after another and then calling it science, what we need to do is interpret our observations and make inferences from them. And once we've observed that water doesn't have a shape of its own, but it conforms to whatever container that it's in, then we can infer that this property is shared with other liquids, like milk or orange juice, those kind of things. And then we can test, we can debate if this is really true or not. Observations really have to do with the very nature of science. Observations yield what we call data. Data is just another word for information. We will analyze and we will interpret data in order to figure out how this data informs our hypotheses, our theories, our educated guesses. And data can be represented in detailed graphs or models, or really just writing down at the most basic level, this is what I saw. And that's kind of what you're going to be doing today. Now, I want to talk about the types of observations. First of all, there are natural observations. Because this is the first part of the scientific method, first we have to observe something from the natural world. Now think about Sir Isaac Newton and his theorizing about the force of gravity. This all came from him not really thinking about gravity in particular, but it came after he made an observation. He watched an apple fall from a tree. This is a natural observation. He saw something happen in the natural world without any intervention on his part. He had nothing to do with it, or no one else had anything. It just happened naturally. And so this is one type of observation. Another type is staged observation. Now, if Isaac Newton had come up with the theory of gravity after him taking an apple and dropping it from a balcony, then his observation would be staged. And a lot of experiments that we do in science come from us first thinking, what if? What if I did this, what would happen? What if I dropped this apple from this balcony? What would happen? In this form of observation, the scientist creates a hypothetical theory from thinking about something in nature, and then he intervenes in nature, he stages something, and then he observes that event or that phenomenon. So this type of observation generally dictates that the experimentation that comes from the observation is recreated. Then there's what is called quantitative observation. This essentially, just let's break it down, it involves numbers. Quantitative, quantity. So after a scientist comes up with a theory based on an observation of something in nature, they start an experiment. And once that experiment is underway, it has to be observed. And the scientist records the observations of the experiment. He collects that information, collects that data, and one type of information that he collects is quantitative. And so this form of observation uses mathematical models, and it relies on the scientist to collect information based on numbers. So back to thinking about the apple, how many apples fell from the tree, or how many apples were dropped from the balcony. This type of observation is common in physics and biology and chemistry, but it always has to do with numbers. And then there's qualitative, meaning it involves qualities. When a scientist performs an experiment that requires observations concerning the quality of what happens in an experiment, this is the type of observation he's doing. This includes the colors of the apples or the shapes of the apples. Did this affect how they fell? It could be what happened to them when they fell. Did they roll to the right? Did they roll to the left? Now, you might dismiss things that are qualitative. Think about back to our talk about Mars. We talked about some descriptive words. We said it was red. That would be a qualitative observation. We saw that it was red. Now, some people will say that this is not important because it doesn't require hard mathematical data, but this is important because we make inferences from the fact that Mars is red. We talked about it's red because of the iron oxide, the rust on the surface. So we got some information about the makeup of the surface. So you need to understand the different types of observation.